Hey there, gamers and curious minds. Welcome back to Channel Name, where we dive deep into the fascinating world of technology and gaming. Today, we're going to explore an intriguing concept that's changing the landscape of gaming as we know it, reinforcement learning. So, whether you're a seasoned player or just starting out, stick around, because this is going to be enlightening. Now, you might be wondering, what exactly is reinforcement learning, and how does it apply to the games we love to play? Let's unravel this concept together. Reinforcement learning, or RL for short, is a type of machine learning inspired by behavioral psychology. In simple terms, it's all about learning from the consequences of actions. Imagine you're playing a video game where you control a character. Every time you make a decision, like jumping over a pit or collecting a power-up, you either score points or face consequences. This is the basis of reinforcement learning. In reinforcement learning, an agent interacts with an environment and learns to make decisions that maximize its rewards over time. Let's break this down with an example. Consider the classic game of chess. In chess, every move a player makes can either lead to victory or defeat. A computer program using reinforcement learning would play countless games against itself or other players. Initially, it might make random moves and lose often. However, as it plays more games, it begins to learn which moves lead to wins and which ones lead to losses, reinforcing successful strategies and avoiding poor ones. This process is often represented using a few key components: states, actions, rewards, and policies. States are the different situations the agent can be in. In our chess example, each board configuration is a unique state. Actions are the possible moves the agent can take from each state. Rewards are the feedback the agent receives after taking an action, like gaining points or losing a piece. Policies are the strategies the agent develops to decide which actions to take in different states. You may ask, how does this apply to more modern games? Let's look at a real-world case. OpenAI's Dota 2 bot, known as OpenAI 5. This sophisticated AI used reinforcement learning to play the complex multiplayer, online battle arena game Dota 2. By playing millions of games against itself, it learned intricate strategies and team dynamics. When it faced professional human players, it showcased remarkable skills, even defeating some of the best teams in the world. This demonstrates how reinforcement learning can lead to extraordinary performance in complex environments. But reinforcement learning isn't just limited to games. It has applications in various fields, such as robotics, self-driving cars, and healthcare. For instance, in robotics, reinforcement learning can help a robot learn how to navigate obstacles by rewarding it when it successfully avoids them and penalizing it when it crashes. Now, let's dive a bit deeper into how reinforcement learning algorithms work. One popular algorithm is Q-learning. In Q-learning, the agent learns a value for each action in every state, known as the Q-value. The higher the Q-value, the better the action is considered in that state. Over time, the agent updates these Q-values based on the rewards it receives, refining its strategy to maximize its overall score. Another well-known method is deep Q networks, which combines reinforcement learning with deep learning. This approach uses neural networks to approximate Q-values, allowing the agent to scale its learning to more complex environments with high-dimensional inputs, like images, which is often the case in video games. The success of reinforcement learning is also attributed to its ability to generalize from experience. Just like you learn to play different games by applying what you've learned from previous ones, reinforcement learning agents can transfer knowledge between tasks, making them incredibly versatile. However, while reinforcement learning presents exciting opportunities, it also comes with challenges. Training an RL agent can be resource-intensive and time-consuming. It often requires vast amounts of data and computational power. Moreover, ensuring that the agent learns the right behaviors without unintended consequences can be tricky. For instance, if an agent is trained to maximize points in a game, it might discover exploits that aren't in the spirit of fair play. As game developers continue to integrate reinforcement learning into their designs, we can expect to see increasingly intelligent and adaptive AI characters, providing players with more dynamic and engaging experiences. So, in summary, reinforcement learning is an exciting field that uses trial and error to teach machines how to make better decisions, enriching our gaming experiences. Whether it's through unbeatable AI opponents or adaptable NPCs that respond to your play style, reinforcement learning is paving the way for the future of gaming. If you found this video enlightening, don't forget to give us a thumbs up and subscribe for more tech insights and gaming knowledge. And we'd love to hear your thoughts. How do you think reinforcement learning will shape the games of tomorrow? Drop your comments below. Thanks for watching, and until next time, keep gaming smart.